Good morning. I am David, Assistant Professor, Department of Mechanical Engineering, Ravuni College of Engineering and Technology. In this video, we are going to study about the Vane pumps from the subject Hydraulics and Pneumatics. Working principle of Vane pump that you can study first. This diagram shows the working principle of Vane pump. Here there is a casing, there is a rotor, there are number of slots available in the rotor. Then number of vanes are inserted into the slots. Then there is an inlet, there is an outlet. When the rotor rotates inside the casing, the area will be differ. So the vanes moves up and down inside the slots. So when the area increases, there is a vacuum. The pressure will be increased. Pressure will be reduced. So vacuum will be produced. So fluid will come inside. So then when the area decreases, high pressure will be produced and fluid gets pressurized and it goes to the required place. There is a working principle of vane pump. So it generally consists of rotor, vanes, rings and a port plate with inlet and outlet ports. The rotor in a vane pump is connected to the prime mover through a shaft. The rotor is connected with the motor. Okay. Next, types of vane pumps. Vane pumps are divided into three types: unbalanced vane pump, balanced vane pump, adjustable vane pump. So first you can see unbalanced vane pump. In practice, the vane pumps have more than one vane. The rotor is offset within the housing and the vanes are constrained by a cam ring as they cross inlet and outlet ports. Although the vane tips are held against the housing, still a small amount of leakage exists between rotor faces and body sides. Also, the vanes compensate a large degree for wear at the vane tips or in the housing itself. The pressure difference between outlet and inlet ports creates a large amount of load on the vanes and a significant amount of side load on the rotor shaft, which can lead to bearing failure. This pump is called unbalanced vane pumps. Here already we have seen there is a casing, there is a rotor, there are number of slots available in the rotor, then number of vanes are inserted inside the slots. So when the rotor rotates, now the rotor rotates in clockwise direction. Just assume. Now, these vanes, when it come in this area, the area will be increased. So, pressure will be decreased. So, fluid will come inside in between the vanes. So, this fluid will be trapped in between the vanes and it will be sent outlet with high pressure because here the area is decreasing. Then balanced vane pump. So the diagram of balanced vane pump is this one. The pump has an elliptical cam ring with two inlet and two outlet ports. So here two inlet and two outlet ports are available. Pressure loading still occurs in the vanes, but the two identical pump valves create equal but opposite forces on the rotor. It leads to the zero net force on the shaft and bearings. So here bearing failure will not be takes place. Thus lives of pump and bearing increases significantly. Also the sounds and vibrations decrease in the running mode of the pump. Next, last type of vane pump we are going to see is adjustable vane pump. So here the position of the cam ring can be adjusted. This casing will be adjusted. So the quantity of fluid come inside into the pump can be adjusted. Some vane pumps are also available with adjustable capacity. This can be achieved by adjusting a positional relationship between rotor and the inner casing by the help of an external controlling screw. So this is the screw. These pumps basically consist of a rotor as usual, rotor, vanes, camring, port plate, thrust bearing for guiding the camring, and a discharge control screw by which the position of the camring relative to the rotor can be varied. So this is just like unbalanced vane pump type. Then applications of vane pump. These are the common application. Vane pumps have various applications for the pumping of following fluids: aerosol and propellants, aviation service, fuel transfer, auto industry fuels, loops, lubrication coolants, bulk transfer of LPG, NH3, LPG cylinder filling, alcohols, refrigeration, freons, ammonia, solvents, aqueous solutions. So these are the common type of applications. To pump this type of fluids, these vane pumps we are using. Thank you.